Today we're going to introduce the idea of limits. Here on the graph we have the function f of x, which is defined as x squared minus x minus 6 all divided by x plus 2. Here we see the point b, which is 10, 7. Now as you can see, I can slide the point down one x increment at a time to 4, 1, 2, negative 1, 1, negative 2, 0, negative 3, negative 1, negative 4. But you'll notice it disappears here. It goes from negative 4, negative 7 to negative 3, negative 6, disappears, and back up to negative 1, negative 4. The problem occurs is when we try to put negative 2 in. As you can see, negative 2 would be a non-permissible value, thus making the denominator equal 0. Well, the question remains, I guess, is if I was to put a point on here, what would be the y value of this coordinate? Now, of course, if I have a graph, I could probably trace it and follow along. But what if I didn't? What if all I had was a calculator and this function? Well, what we could do is we could create a table of values. Now obviously, as you see, if I put negative 2 in, it's going to come out error, because obviously it's undefined. But negative 2 is the only number I cannot use. So what I could do is see if there's a pattern. For example, I could put negative 1 in. The output's negative 4. Now negative 1 is 1 unit away from negative 2. Let's see if we can get a little closer. Maybe I can go a half a unit away. And now it's negative 4.5. Now let's see if I can get really close. Say negative 1.9. Well, now as you see, as the x value is getting closer and closer to negative 2, the y value is steadily increasing. But it almost looks like it's getting closer and closer to a value. Let's try negative 1.999. When I put that in, now of course our calculator is showing negative 2, but in reality it's actually a bunch of 9s and it's rounding. And when I click over at negative 5, it's also rounding to negative 5. So it seems like as I'm bringing the x value and closer to negative 2, the y value is getting closer and closer to negative 5. Just like with the slope at a point, we should also check the other direction. So let's see if I go a little over negative 2. Now due to the limitations of the calculator, it rounds to negative 2 on the screen, but if I scroll over, I can see that it's negative 5.001. So as we can see, both graphically, as I get close to negative 2 on both sides, the graph's getting closer and closer to negative 5. As well as algebraically, as I put numbers closer and closer to negative 2 in from both sides, the graph is getting closer and closer to negative 5. What that means is we can say that the limit of the function as x approaches 2, or negative 2, is negative 5. Now the question is, how do I write that in a symbolic language so that everyone can understand? Well, we use the notation LIM to represent limit. What we then write is under limit is we write x, then a right arrow, negative 2. Now what this means so far is the limit as x approaching negative 2 of the function is equal to negative 5. This means as I'm getting closer and closer to negative 2 as an x value, the output or the y value will be getting closer and closer to negative 5.